KalabawCNC Maker Squad. So hey guys, we're going to have a new college intern with us, helping us out on the project, and he's going to be doing a lot of the 3D modeling and some of the engineering work for the 3D printer project, which is coming up soon. As you can see, again, I apologize for the mess behind me. The shop is, as you've seen in the videos, still very much in progress. Again, I have to get the garden finished first, and then I can start working on the outdoor shelving, so I can clean up the rest of the garage and the shop space, so I can actually start to fabricate some of the projects in here. So introduce yourself.
I'm BJ Burrows. I'm a mechanical engineering major at Auburn University.
And what are you interested and passionate about?
I really like sports and cars, pretty much guy things. I'm excited to be helping with this project, and I'm pretty passionate. I like engineering stuff, obviously. That's why I'm going for the degree. So
right.
Yeah.
Okay. Well, that's cool. And what do you want to get out of the project? What excites you and interests you about this?
I'm trying to get better CAD drawing skills, and I'm happy to be helping a what's it called, open source project like this. So
yeah,
should be exciting.
Okay. So just a little bit of an overview about what we're going to be starting with, because this is a little bit of a long project, but you can contribute as long as you can, or as long as you're able to. So we're going to start off with a very basic 3D printer. So it's like sort of a desktop 3D printer, right? It prints plastic, various kinds of thermoplastic. Okay. So you have to become familiar with thermoplastics. This will be different kinds of plastics like ABS, polypropylene, high-density polyethylene.
Yeah.
So you'll learn all that stuff. And some of the engineering about how to build a 3D printer. Just a heads up, we're going to be building it like a Cartesian coordinate printer, so it's an XYZ.
Yeah.
The bed will be stationary.
Okay.
And the reason why is because we're going to be reusing that architecture in the subsequent design iterations. When we get to larger builds, the build plate needs to stay stationary, especially for large, heavy objects. And it gives us an added bonus in the fact that we're going to have an open frame, so we can actually do a lathe down the middle. Okay. So you can have like a 5 or 6 axis CNC machine.
Okay.
So we're going to be going in that direction. We'll kind of see how that goes. We'll start with the small desktop 3D printer. And then we're going to move to reusing that design to make it into a small desktop CNC machine.
Okay.
And from there we can actually make circuit boards and carve wood.
Okay.
Okay, or maybe some light metals, like mostly probably aluminum. But then we're going to get to the big stuff, which is a larger, probably, I don't know, like maybe that big or larger. That'll be a big, probably be about like this. That'll be a larger 3D printer. Okay. We'll start with the 3D printer again, and then we'll move into the CNC machine. And once we have both of those, then we'll reuse that architecture again to do a metal 3D printer. Okay. And that's where we're going to get some interesting stuff. So viewers, consider becoming a Patreon supporter. You'll be supporting, helping to support BJ in his college, as well as helping this project to develop. So all of those things are going to be really helpful and beneficial.
Yeah.
For you, for me, for the project, for everybody.
Yeah,
okay. I mean, this is a big innovation thing. We're going to be pushing into areas where nobody's ever done anything before.
Yeah.
So some of this stuff could lead to a master's degree or stuff down the line.
Oh,
you
yeah.
could actually get publications and some exciting things. And ultimately, there could be commercial applications. I mean, this thing is going to be big. We're going to be able to scale it because, like I said, it's back to that open architecture. So if somebody wants to buy a 3D printer, a metal printer, or a plastic printer that does the materials that we're going to be working with, such as steel, and aluminum, copper, brass, those things, then they could get it built as big as this garage.
Okay.
So that's huge.
Yeah.
It would probably cost quite a bit of money, but it's an open architecture. It's an open source design, and we're going to make it available. So, yeah, I'm excited to have you on board.
Thank you for having me.
Absolutely. Let's talk logistics, and we'll get this thing going.
Sounds good.
All right. Take care, guys.
Bye.
See ya.